Hello everyone. Let's talk about synthetic division and the remainder theorem. In my previous video about synthetic division, we learned that sometimes our remainder might be equal to 0 or a non-zero digit. Now, what is the relationship between synthetic division and the remainder theorem? Before we proceed, always remember the following points. The remainder theorem states that when a polynomial p of x is divided by x minus a, other books uses x minus c or x minus r. The remainder is p of a. If the remainder is equal to 0, then x minus a, which is your divisor, is a factor of p of x. Now, let us have this polynomial p of x is equal to 2x cubed minus 8x squared plus 19x minus 12 divided by x minus 3. So, to find the quotient easily, let us use synthetic division and see how is it being related to the polynomials, the remainder, with the given polynomials using synthetic division. So let us arrange the coefficients of our dividend in a row. So you have 2, negative 8, positive 19, negative 12. Then divide this by our divisor, x minus 3. What is the value of our x? X minus 3 is equal to 0, x is equal to positive 3. So we have here positive 3. Then, next thing we have to do is to bring down the first coefficient, which is 2, and then multiply it by 3. So you have 2 times 3 is positive 6, and then you add negative 8 plus 6 is negative 2, and then multiply it again by positive 3, it gives us negative 6, and then you add it to 19, we have positive 13, multiply it again by positive 3, so it gives us positive 39, and then you add it to negative 12, it gives us positive 27. So, as what you have learned before, that the third row in our synthetic division, the last number in our third row is what we call the remainder. Now, what is the relationship of this remainder in our polynomial? It states there that if our polynomial, this one, is divided by this one, x minus 3, where our x is equal to 3, then it says that p of x is equal to our remainder. So, if we are going to replace the value of our x with 3 here in our polynomial, the resulting number is the remainder. It gives us the remainder. So let us try to check if it is really true. So p of x is equal to 2x cubed minus 8x squared plus 19x minus 12. So p of, let us check, this is our divisor. P of 3 is equal to 2 times 3 cubed minus 8 times 3 squared plus 19 times 3 minus 12. Let us simplify. 2 times 3 cube is 27. Minus 8 times 3 squared is 9. Plus 19 times 3 is 50. 57 minus 12. So we have P of 3 is, that is 54. 2 times 27 minus 8 times 9 is, we have 72 plus 57 minus 12. So P of 3 is equal to 54 minus 72 plus 57 minus 12. That gives us 27. So it is true about the remainder theorem using synthetic division, and P of x is equal to R. So that's it. P of 3 is equal to 27, which is actually equal to P of x is equal to our remainder. So example number 2, we have x to the 4th minus 3x cubed plus 2x minus 2 divided by x plus 2. Let us examine our dividend. If it is arranged in descending order, so 4, 3, there is no term here that contains 2 as the exponent. So we have to write 0 as the coefficient of that missing term, so that it becomes complete. So we have now 1, we have negative 3, positive 2. Now we have 0 first for 0x squared, then we have positive 2 and then negative 2. Next, we have to divide it by, okay, our divisor here is x plus 2 is equal to 0. Let us find the value of our x. That is the opposite of positive 2, so we have negative 2. So we have negative 2 here, and the next step, we have to bring down the first coefficient, which is 1. Multiply it by our divisor, negative 2. 1 times negative 2 is negative 2, and then you add this one, negative 3 and negative 2, we have negative 5. Multiply it again by negative 2, so we have positive 10. Negative 5 and negative 2 gives us positive 10, and then you add, that is 0 plus 10 is 10. So you have multiply again, you have to multiply it again by negative 2, so we have negative 20. You add it to positive 2, so it gives us negative 18. Negative 18 times negative 2 is positive 36, and then you add it to negative 2, it gives us positive 34. So 34 here is our remainder. Let us check if it holds true for P of negative 2, it will give us 34. So P of x is equal to our remainder. That means P of negative 2 will give us 34. Let us check. So we have P of negative 2 is equal to negative 2 to the 4th power minus 3 times negative 2 cubed plus 2 times negative 2 minus 2. Okay, next we have P of negative 2 is equal to negative 2 multiplied by itself 4 times, it gives us 16. And then negative 3 times, what is negative 2 cube? Gives us negative 8. Negative 2 times negative 2 times negative 2 is negative 8. Then we have 2 times negative 2. It gives us negative 4 minus 2. Simplify. P of negative 2 is, we have 16, negative 3, and negative 8 plus 24. Then we have negative 6. Then P of negative 2 is 16 plus 24 minus 6 is, we have positive 34. So it is true. P of negative 2 is equal to our remainder, which is 34. Okay, we have example number 3. 2x cubed plus 5x squared minus 3 divided by x plus 1. Let us check our dividend. So we will not be mistaken when we are going to arrange the coefficients in a row. So 3, 2, we can see that there is no term that contains the linear term. So this should be 2x cubed plus 5x squared plus 0x minus 3. 0 to represent the coefficient of our linear term. So let us arrange 2, 5, 0, and negative 3. And then divide it by our divisor. So our divisor is x plus 1. Find the value of our x. Equate it with 0. So x is equal to negative 1. So it is negative 1 here. And then let us bring down our first coefficient, that is 2. And then multiply this by negative 1. It gives us negative 2. Put it below 5. And then you add positive 5 plus negative 2. It will give us positive 3. And then you multiply it again by negative 1. So it will give us negative 3. So you add negative 3. 0 plus negative 3 is negative 3. And then multiply it by negative 1. So negative 3 times negative 1 is positive 3. Then you add this again. Negative 3 plus positive 3 is equal to 0. So our remainder here is 0. Let us check if it holds true for P of x is equal to the remainder. Here, our x is equal to negative 1. So, P of negative 1 is equal to 0. If that is true, let us see. So, P of x is equal to 2x cubed plus 5x squared minus 3. And P of negative 1 is equal to 2 times negative 1 cubed plus 5 times negative 1 squared minus 3. Let us check. P of negative 1 is 2 times negative 1 multiplied by itself 3 times. So it gives us negative 1 plus 5 times negative 1 squared, that will give us 1 minus 3. So we have P of negative 1 is equal to negative 2 plus 5 minus 3. So, P of negative 1, negative 2 plus 5 minus 3 is equal to 0. So, it is true that P of x in our given polynomial is equal to our remainder, which is equal to 0. So, it is actually easy now for you to solve or see for the remainder of any given polynomial by just replacing P of x with the value of our divisor, which is x, and see what the remainder is. And it says also that if p of x is equal to 0, then your divisor, which is this one, x minus 1, is actually a factor of the polynomial 2x cubed plus 5x squared minus 3. So, remember that if p of x is equal to 0, in this case, p of negative 1 is 0, then x minus 1 is a factor of this polynomial. Example number 4, p of x is equal to 3x cubed plus 13x squared plus 9x minus 15 divided by x plus 4. Find the remainder. In here, we can directly solve for the remainder by just using x plus 4 to evaluate our polynomials, replacing the value of our x with our divisor here, which is x plus 4. So, to find the value of our x, so we have x plus 4 is equal to 0, x is equal to negative 4. Let us replace this negative 4 to evaluate the function or the equation, polynomial equation, 3x cubed plus 13x squared plus 9x minus 15 without using synthetic division. So, p of p of x is equal to 3x cubed plus 13x squared plus 9x minus 15, and evaluate when p of x is when x is equal to negative 4. So, 3 times negative 4 cubed plus 13 times negative 4 squared plus 9 times negative 4 minus 15. So, p of negative 4 is 3 times, what is negative 4 raised to the third power? That is negative 64 plus 13 times 16. Then we have 9 times negative 4. We have negative 36, negative 15. So, p of negative 4 is equal to, this is negative 192 plus 13 times 16 is 208 minus 36 minus 15. So, p of negative 4, evaluating these numbers, we have negative 35. So, our remainder is negative 35. So, p of negative 4 is negative 35. That is our remainder. Number 5 is x plus 2, a factor of x cubed minus 2x squared minus 3x plus 10. Now, you have to remember that if p of x is equal to the remainder, and if the remainder is equal to 0, then x minus c or x minus r or x minus a is a factor of the given polynomial. For this question, is x plus 2 a factor of this one? So, let us check And let us evaluate this polynomial replacing the value of our x with our divisor x plus 2 and replace negative 2 as the value of our x in p of x. But how did we get negative 2? So we have x plus 2 that is equal to 0, x is equal to negative 2. So let us check if p of x is equal to x squared minus 2x is equal to x cubed minus 2x squared minus 3x plus 10. Let us see and let us evaluate if p of negative 2 is equal to 0. So you have negative 2 cubed minus 2 times negative 2 squared minus 3 times negative 2 plus 10. So we have p of negative 2 is equal to negative 2 cubed, that is negative 8. Then negative 2 squared is positive 4. Then negative 3, negative 2, that is positive 6 plus 10. So we have p of negative 2 is negative 8, plus 16. So that is p of negative 2 is equal to negative 16 plus 16. That is p of negative 2 is equal to 0. So since our remainder is equal to 0, then what is our conclusion about this one? Is x plus 2 a factor of x cubed minus 2x squared minus 3x plus 10? The answer is yes, because the remainder is 0. So I hope you learned something from this video. Thank you for watching and until our next video.